Okay, so let's get into a few more details of these descriptive, predictive and prescriptive analytics, right? So descriptive analytics, as I said, people have been doing for a long period of time, right? And that's mostly done for Excel kind of data sets. So data sets which sort of fit on an Excel table, okay? So now in an Excel sheet, there are in general two kinds of columns, right? So one of them are numeric columns. So these columns are more like salary of a person or tax or height of a person and so on. Okay, so that is what is called as quantitative data also, in other words, right? And there are other kinds of columns which are categorical columns. So for example, occupation of people, so there could be probably like 10 different occupations, right? Hometown, so that could be like cities, and maybe there is a limited set of 50 cities that you care about and so on. So and that is what is called as qualitative data. So usually when people talk about descriptive analytics, they talk about trying to represent summaries of both qualitative and quantitative data as they make sense for the business problem. So for example, for qualitative data, you might basically want to put out that, hey, 10% of the people work in IT sector in India, right? So that 10% now can be given as percentages, or you can draw a pie chart of all the occupations and then represent a small pie of 10% in that pie chart for IT, right? And so on. So there are other ways of showing this qualitative data as well. And then in quantitative data also, you can either represent it basic numbers itself, and then there are various kinds of statistical measures like mean, median, mode and so on, which people typically do. There are also things like median, quartiles, deciles. In fact, as part of our basic statistics, we are going to cover this part significantly. So how do you really represent summaries of data? How do you come up with various summaries like 5-point summary, box plots, stem and leaf plots and so on. So we will cover these in detail, but that's what is descriptive analytics, right? So you do not predict about the future. It's all about summarizing whatever data you have so far, right? So that's descriptive analytics. Now beyond descriptive analytics, the next step which has become very popular is predictive analytics. And here are a few more little detailed discussion about predictive analytics, right? So predictive analytics is applied not just on text data, but also on Excel kind of data as well. So you can actually use the same Excel kind of data, and now rather than just coming up with summaries that, hey, how many people live in a particular city or city-wise distribution of people and so on, what you want to do is interesting things. Like given this data set, can I learn how to predict somebody's salary based on the other columns, right? Where salary is one of the columns in the table. Okay. So and then what can be done? This learned thing is called a model, and this model can then be deployed over new people that you don't know much about. You don't know their salaries, but you know other column values, and then you can use this model to predict their salaries. Okay. And that's the predictive part in predictive analytics, right? So you can do regression, you can do classification. There are a whole bunch of things which are a part of predictive analytics. What these mean will become clearer as we go through the next few slides, right? So in fact, predictive analytics is not just about machine learning. Machine learning is one part of predictive analytics, but there's other stuff like figuring out patterns and then figuring out what is abnormal which does not follow those patterns, right? Also it is about scoring. So essentially, for example, when you search for something on a search engine, the search engine looks all over the web and then comes up with a set of results. How does it recommend those results, right? When you go to a doctor and sort of talk to them about your problem, of course a doctor recommends medicines, but how does the doctor recommend? By scoring things, right? But that's manual. Can we do it automatically is the question, right? So that's that. And then as part of predictive analytics also, whatever predictions you come up with, it's nice to visualize it, visualize the predictions so as to make better sense of them, okay? The last thing is prescriptive analytics, and in prescriptive analytics the idea is to basically make prescriptions, and across domains you will find these kind of applications of prescriptive analytics. So how to optimize pricing, how to set the right price, and that's a problem that every retail guy faces, right? How to spend the marketing dollars. I have some budget. Should I do TV ads? Should I do ads in newspapers? Should I basically put ads on social media platform, on ad exchange and so on? and how much money should I put in all of these, right? So that's basically marketing dollars. So there are automated systems which can prescribe you these things, right? How to suggest a medicine or treatment to a patient. Now you would ask, hey, why does one want automated system to prescribe that? There are doctors, of course, to do that. But in countries like India, the doctor to patient ratio is very, very skewed. There are hundreds of patients for every doctor. And especially when you go to remote areas of India, you would find that there are hardly any doctors available. And in those cases, of course, it will be really helpful if there's an automated system which can at least help them with some basic analysis, right? So this automated system, you can call that as a dial-a-nurse system in some senses, automated dial-a-nurse system, and those kind of systems can then tell you basic advice that what treatment or what medicine can make sense. Of course, these systems should be intelligent enough to figure out if there is something severe, and then they can refer back to a particular doctor in the city or something of that sort. But that's all prescriptive. So also how to find the right patient for clinical trials. These pharma companies undergo a whole bunch of clinical trials where to certify if a medicine works or not, they have to basically run it over a set of patients, and these are real human patients. Now different drugs are for different things. So if a particular drug is supposed to be powerful for stage 2 cancer, these guys need to really get 100 patients which are suffering from stage 2 cancer, a particular kind of cancer, and have them consent that it's okay to run these trials over them. Pharma companies have a hard time figuring such patients for clinical trials. Can I use social media data to suggest these guys for pharma companies, right? So that's that. How to decide the best route for an Amazon truck. Okay? So Amazon trucks run all over the world shipping products, right? They move products from warehouses to smaller warehouses and finally to customers, right? Now depending on the demand, depending on who bought what, they have to decide what product goes in this truck and where, right? So considering the number of trucks that ply all across the world, right, and also considering various road conditions and so on, there are a whole bunch of optimization parameters that they need to tune. Okay? How to really decide best route for each of their trucks, right, is also a prescriptive problem. Predict and prescribe, recommend the best set of routes. Okay? Now recommendation systems are everywhere. So in fact, on Facebook there is a recommendation system which sort of suggests friends, right? On Monster there is a recommendation system which recommends jobs. On carvale.com there's a recommendation system which suggests cars, right, if you are looking for a new one, right? TripAdvisor, there's a system which sort of tries to recommend a trip to you, and Make My Trip. All of those try to promote various trip packages, right? So how do they figure out what thing to recommend to whom, right? So that's also a part of prescriptive analytics, prescribing each of these things, right? Lastly, for this is an example from more of the oil industry. So for oil production, before they set up a new field, these guys need to know where it is good to dig, right? So they want to dig at a place where they can expect a huge amount of oil, and that is why figuring out or recommending these places is also an important thing, right? So these are just a few use cases, right? This is just the tip of the iceberg. There are a whole bunch of use cases all across industries where prescriptive analytics has made a significant difference, right? So now to do all of this analytics you need data, and fortunately we have lots of them. Okay. In fact, Gartner published a study where they tried to figure out among all of these different analytics scenarios, descriptive, diagnostic, predictive, prescriptive, which of them is the best, and how much on average does it make sense for a company to invest in these scenarios, right? It turns out that while descriptive analytics is not bad, of course it's good to do, right? And that's what people have been doing traditionally. What impacts the most is this prescriptive analytics piece. Okay. So and why not? I mean, prescriptive analytics is basically telling the business directly, recommending to the business directly what is the best action to do at this point, right? While other kind of analytics really require some human processing after whatever has been done. So after one looks at a descriptive report of what kind of profits I made across various stores in a supermarket, one has to sit down, think, why did I not make profit here? What can I do to improve profits and so on? While this guy is going to directly tell you, it's going to directly prescribe, hey, what is the next step that you should take, right? Maybe increase the manpower at a particular store, maybe do more marketing for that store, maybe take up steps to increase the efficiency of the workers in the store, and so on. Okay? So that's that. Now to do all these things, you need a huge bunch of data. And we already said that there's a huge amount of data, but it turns out it's not just that there is data in typical traditional domains, right? So of course domains like IT, domains like search, web search, they all of course have very large amounts of structured data available, right? But what is new is that data is being generated and captured very rigorously across domains as well, where traditionally data was never saved in such a rigorous way. For example, oil and production, will you really want to save data there, right? In agriculture, who cares about, what was the yield 10 years back at a particular patch of land? But people have started caring about that now, right? So who cares about what was the grades all across India of all students who are studying in various government schools? Did people care? Not so far, but now yes, they have started recording that data. In fact, on this slide, you see some of these different kinds of data which are available in the SCM domain, the supply chain management domain, okay? So even in these kinds of domains where traditionally data was not being stored and analyzed significantly, there's a huge amount of analysis which is being done on top of them. Thanks to the Hadoop wave which came in about 10 years back, people realized that, hey, it is possible to store data. It's possible to at least do some basic descriptive analytics on it. But now people have gone beyond and understood that, hey, it's possible to also do some sort of nice prescriptive and predictive analytics on top of it. Okay. So now let's look at what is a typical big data analytics process cycle. Okay, so many of us know about the software development life cycle, right? And there are various steps like coming up, talking to the customer, getting the problem statement, designing, implementing, review, whatnot, right? So that's a typical software development life cycle, and this is what I call as a big data analytics process, okay, or the big data analytics life cycle. Okay, it consists of these 7 main steps. Okay, the first part is defining the business need, and this is going to be very similar to a software development life cycle, but there are going to be differences, right? So first part is similar. You basically need to define the business needs. What is it that the business wants, right? Explore the data. So then work with the business to figure out what kind of data they have, right? And then explore. Can you try to analyze the data, try to clean the data nicely, and try to figure out if it is possible to actually answer the business need based on that data. And if yes, then from among these two large data sets, what is that small part of data set which will help you answer this business need? Okay. So once you have gotten the data, predict what's likely to happen, in the sense, can you sort of try to answer the business need? Okay. This involves building prediction models, right, based on this data set, okay, and making prescriptions, right, making predictions, right. So after you have made predictions, what you want to do is to optimize, find the best solution. You have made predictions, you have tried various candidates, you have predicted how good each of those candidates work, right, in various scenarios, and then optimize, try to find the best solution. Okay. After you found the best solution, make a decision, measure the outcome. So deploy that solution, deploy that machine learning solution, and then measure the outcome. There are many metrics depending on the kind of solution that you are designing, right? And we'll talk about those metrics. This is a very generic picture. When we will over time we will get into specific use cases and we will understand each of them much more in detail. Okay. But once you have come up with a solution, once you have decided that, hey, this seems to be the best strategy, go ahead, deploy it, right? And then keep measuring, keep measuring the outcome, and then see if it has really driven the profits, right? So update the system with the results of the decision. So once you have the decision, this is basically more of like a feedback loop. Okay? update the system that, hey, based on this decision, I was able to make so much of profits, right? And then that could go back and then help you retrain and rethink about the entire process altogether. Okay. Now going a little bit in detail on this slide itself. Of course, we'll go in detail when we take up individual use cases in a particular industry and so on. Going a little bit in detail, analyzing the data. What does this mean? Okay. So when I say analyzing data, it involves, so remember what you have basically, say, some client, maybe in healthcare, right? Say some hospital comes to you, tells you, hey, can you help me let's say this hospital is doing cataract surgery. So this hospital tells you, hey, there are going to be many patients which come for cataract surgeries to me, and this doctor wants to know, can you help me decide the lens number that I should put in each of these patients, right, during the cataract surgery. Now doctors basically have a set of bunch of rules based on which they do that anyway. Okay. Now some of the cataract surgeries are super successful, where after the cataract is done, the patient is as good as new eyes, right? Doesn't need any specs, nothing, right? But some surgeries, of course, the lens gets good, it gets better, but oftentimes you will need to put external lens, external specs, right? So that happens because the power of the lens that was inserted as part of the cataract surgery may not be the optimal one. Okay? How can you figure out that optimal one? Okay? Now you sit down with this guy, right, with this doctor, and then they give you access to their data sets. Now data in the healthcare industry, although it is very good, is not really as good as in other industries. Okay? What could happen is that there is data across say 5 centers, and each 5 follow their own database schemas. So first you have to do some sort of a transformation, so as to basically integrate data all across these. So data integration is this process where you get data from multiple sources and somehow you need to integrate. And what are the challenges? There are insane number of challenges. Some guys might be using 6x6 as a scale to measure eyes, while some guys may be using 20x20 scale, different units basically, right? Some guys may be using kilometers, some guys use miles, and so on. So data integration is a big challenge, right? Data cleaning, so some of these things will have some missing values, so some values were not recorded. What do you do with them, right? Data reduction, you have insane amount of data, all you want is a specific part of the data for your current business need, right? How to get that part, right? Data transformation, data discretization, many steps. Again, we'll go into details when we really talk about them. In fact, this entire thing will itself be a large lecture, right? But that's what I mean when I say analyze the data, right? So after analysis, one has to do predictions, and this prediction part itself is a sub process, so to say. Okay, you've already done some part of this process, so you've already converted the real world problem into a prediction task. So basically, this doctor came to you saying, how can you help me make my cataract surgeries more effective? Okay, and we already figured out that, hey, predicting or recommending the right lens number is the prediction problem that we can help this guy with. Okay, so that's the first part, converting the real world problem into a prediction task, which we have done as part of this process so far anyway. Okay, gather training data. So after doing all this analysis, the clean data, the clean gold data that you have is what you have already gathered. And now what do we mean by training data? So remember, we are going to build a model here. So we are going to train this model, so to say. Okay, and that is why we call it training data. Okay, so this data would include past cataract surgeries that this doctor has done. Okay, and therefore it will talk about, hey, when this patient came, patient demographics, so age and what was that, and then what kind of eyes this guy already had, what is the number in various technical terms, right? And then also other kinds of parameters that these folks measure before doing a cataract surgery. Okay, and then this data will also have, when a particular lens number was inserted, what was the surgery outcome. Okay, so whether the patient had a 0 eye number, in the sense he had perfect eyes after the surgery, or there was some residual number which was left, right? So that's called training data. Data about past cases, data from history which can be used to train the model. Okay. Now it's good to say data, but in general it's best to structure it, right? And each of these columns is therefore called as features. So after this part, what you will get is an Excel table, so to say, and in that Excel table, what you can do is to have each column representing various features or signals which help you solve the business problems, predict the final lens number. Okay, and that is what the business problem was. So there need to be signals that you need to capture. Okay. Once you have these signals and the nice data set, you can train various kinds of models and then finally evaluate the model. Okay, finally evaluate how good your model is doing by actually deploying it and then trying to measure the outcome. Okay, so let us just take yet another example, and an example which is much closer to everyone, to make the point even more clearer. Okay, we already took a healthcare example, but maybe another one serves better. Okay. Let's say that you are you are in the last year of your campus, okay, and you want to get placed, right? Many companies come and visit campuses. Let's say Microsoft is one of those companies. Okay, you are the representative of the class. So what you want to do is to basically build a system, automated system, which takes somebody's resume, and then takes the pitch that Microsoft made when they basically visited your campus and tries to figure out whether this guy will pass interviews or not. What is the probability? So predict if this guy pass the interview, will pass the interview and get a job at Microsoft or not. Okay, that's the problem. Now, and that's what we have done in the first part. The real world problem is that you want to figure out which company will this guy get placed into, right? And we have converted it into a binary problem, saying here is the guy, and given Microsoft, will he make it or not? So the decision needs to be yes or no. The prediction needs to be sort of yes and no. Okay. So you need to get the training data. Now where do you get training data in this case? Well, you can get training data from your seniors. So folks who both got selected as well as who did not get selected. Okay. Now it's not very intuitive. Why do you need data about folks who did not get selected at Microsoft, right? But in general, to learn anything better, even humans need both positive cases and negative cases. And that's how even machine learning works. You need both positive cases and negative cases to learn something better. Okay. So you need details of folks who got selected for Microsoft and who did not make it. Okay. And what kind of details? Now then you start thinking, hey, what kind of features or what kind of signals would sort of relate to this decision whether this guy will make it or not. Okay. And then immediately, from a domain perspective, you can think what kind of things will influence the decision. So years of job experience, previous companies that this guy was at, keywords, so do you have like machine learning, AI, ML in your resume or not, and so on. Okay. So once you have that kind of data, now what you need to do is to really train models and tune parameters. Now, I'm not going to go into details of what those models are, but because we have dedicated lectures for each of those models specifically, right? But train any of those models, and finally what you have is a software, a model which you can deploy. And then now a new student comes in, you can basically try to predict whether he will make it to Microsoft or not. So, and after predicting, you can actually see the outcome, actual outcome, compare the two, and then figure out how accurate the model is. Did you learn it really well? Were there issues with it? And that's measured in terms of these measures. Again, we'll have a dedicated session to talk about what those individual measures are, how to compute them, and so on. Right? But in general, all of them tend to sort of signify accuracy in some senses. Okay. Once you have done these predictions, the last step is essentially, or the fifth step is basically to optimize, find the best solution. Okay. You have built various these models, right? And there are many candidates. Say for example, there are many candidate medicines that can be recommended. There are various candidate lens numbers that can be recommended to this patient, and so on. Okay. Now once you run this model, what you will get is basically a prediction, and based on those predictions you can actually suggest what is the best one. Okay. The best one that is suggested should be deployed. So essentially if the system said, hey, this is the lens number that makes sense, put it in the user's eye, and then try to figure out how good this kind of recommendation is working. Okay. Of course, in case of cataract, you can't really figure out just based on one instance, right? Just based on this surgery, did it go well or not. Okay. And therefore the results will not really come the next day. Okay. You'll have to wait after the model is deployed. In some cases you'll have to wait for a few days, few months to figure out how good the model is doing. Right. But in other cases, some other cases it could be faster. Right. But whatever be the point, after you deployed the solution, wait for some time, do predictions on a few instances, and then measure all of these metrics. In different domains you will require different metrics. Right. Different domains, different use cases, you will require different metrics. Look at them and then try to make sense out of them, that hey, is the model doing good as you expected, or do you need to do some changes, right? Pass on that feedback and then redo the cycle. That's what a typical business analytics process is all about.